Hello, welcome to Yes Spark STEM Kits, brought to you by the High Plains Library District and Yes Fest. In this month's installment of Yes Sparks, we're going to learn about probability. What is that? Well, when we say what the probability is of something happening, it means the same as the odds or the chances of it happening, and we're going to use those terms interchangeably. In your kit, you should have a coin, a pair of dice, a deck of playing cards, and a Chance Your Own Adventure storybook titled YesBot Plays the Odds. This is a story about YesBot's journey to meet a friend for lunch, and the course of that journey is decided at points by probability. You and YesBot will use your coin, your dice, and your playing cards to determine what will happen. In the back of the storybook, you'll find a detailed explanation of those activities and the math involved, and in this video, we want to show you some basic concepts of probability. Unless someone has a weighted coin, loaded dice, or marked cards, coins, dice, and cards are time-honored tools for generating random results of equal probability. The odds of a coin landing on one side are the same as for the other side. Similarly, the odds of landing on one side of a die are the same as any other. And the odds of drawing one card out of a shuffled deck of cards are the same as for any other card. The odds of getting a certain outcome can be expressed as a fraction or a percentage. To figure the odds of separate independent outcomes happening in sequence, you can multiply the odds of the first outcome against the second outcome, and then against the third, and so on and so on. And the last concept, the odds of an outcome happening and the odds of it not happening added together always add up to the whole number 1. Let's look at one way that we can express the probability or odds of a certain outcome happening. When we flip a single coin a single time, there are only two possible outcomes: heads or tails. So each time you flip the coin, the odds of getting heads is 1 out of 2, which we can express as a fraction, 1/2. We could also express this as a percentage, as 1/2 is the same as 50%. When someone refers to the probability of a situation as even odds or a 50-50 chance, they mean the odds of something happening or not happening are each 50%. Now, if you flip the coin twice, there are 4 possible outcomes of those flips. You could get heads, then another heads. You could get a heads and then a tails. You could get tails the first time, then heads, or you could get tails both the first time and the second time. As you can see, only one of those 4 outcomes will give you heads both times, so your odds of getting heads both times are 1 out of 4, or 1/4, or 25%. We saw that the chances of getting heads both times is 1/4. We could always list all of the possible outcomes to figure out those odds, but if we were flipping the coin 100 times or rolling a dice multiple times, that would get really unwieldy. We can get to the same answer quickly and simply by using a little math. In particular, we're going to use something called the specific multiplication rule, which says that the probability of 2 independent outcomes or events happening in sequence can be determined by multiplying the probability of the first event by the second event. When we say independent, we mean that any of the events does not affect the probability of the other events. The math behind this is as follows. The odds of getting heads in the first flip is 1/2. We multiply that by the odds of getting heads on the second flip, which is also 1/2. And we get, when we multiply the numerators, 1 times 1, and then the denominators, 2 times 2, we get the fraction 1/4, or 25%. This specific multiplication rule can be applied to an unlimited number of independent events. To figure the odds of rolling a 5 3 times in a row using a single die, the math is the same. Remember that the odds of rolling a 5 on each individual roll is 1 out of 6, or 1/6, regardless of what the outcome of the previous roll was. So 1/6 times 1/6 times 1/6 equals 1 over 216. 6 times 6 being 36, times 6, 216. which equals 0.463%, which are some really bad odds. So there are 216 possible outcomes of rolling a die 3 times, and only one of those outcomes will give you a 5 3 times in a row. Now let's talk about rolling a pair of dice compared with rolling a single die. If you roll a single die, the odds for getting any of the 6 numbers on the die are equal, 1 out of 6. Or 1/6. But if you roll 2 dice and add up the number of pips, that's what we call the dots on them, on both dice, we can get a number anywhere from 2 to 12. But the odds of getting each of those added numbers are not equal, and that's what the dice game craps is built upon. Have any of you ever shot craps? Taking a look at this chart, we can see all 36 possible outcomes. You can see there's only one way to get a 2, which is known in craps as snake eyes, and only one way to get 12, which in craps is known as boxcars. But there are 6 ways to get 7, or craps. So the odds of getting a 7 is 6 over 36, or if we reduce that fraction, 1/6, which is the best odds of any of the total numbers. One of the axioms that probability theory is built upon is that the sum of the probabilities of all outcomes equals 1. For example, we saw that the odds of rolling a 1 on a single die is 1/6, which is also true for 2, 3, 4, 5, and 6. So if we add up all of those probabilities, all of those 1/6 together, they equal 6/6 or 1. And what this means is that if you know the odds of an outcome happening, you can easily figure out the odds of it not happening. Just subtract the odds of it happening from 1. So if the odds of rolling a 3 are 1/6, then the odds of not rolling a 3 are 5/6, or 1 minus 1/6. Another type of question about probability will ask what the odds are that something will happen at least once in a certain number of tries, such as if I shuffle a deck of cards and then draw one card and repeat that process 4 times, what are the odds that I'll draw an ace at least once? There are 52 cards in the deck if you take out the joker, and 4 of those cards are aces. From a full deck, the odds of drawing an ace are 4 over 52, which reduces to 1/13, or 7.7%. To find the odds of drawing an ace at least once in 4 tries, we need to find the odds of not drawing an ace at all in 4 tries, and then subtract those odds from 1. Let's do it. The odds of not drawing an ace in 1 try is 12 over 13, because remember, it's the odds of drawing an ace subtracted from 1, which is 1 minus 1/13 equals 12/13. So for 4 tries, we multiply 12/13 times 12/13 times 12/13 times 12/13, which results in 20,736 over 28,561. Since that's the odds of not drawing an ace at all, the odds of drawing one at least once is 1 minus 20,736 over 28,561, which gives you 7,825 over 28,561, or 27.4%, which are better odds. Now, if you wanted your odds to be better than even of drawing an ace at least once, you would need to increase your number of tenths to 9. So many numbers, such big numbers, so much math. We hope you've enjoyed learning a little bit about probability through this month's Yes Sparks Take and Make STEM kit. Please join us again next month for another fun activity.